So this problem says graph the polar equation. So we're just going to graph this polar equation here. So again, we're going to do the R theta table in order to find enough points to graph. Now again, some people ask, how many points should I have? And I think on average, I would say at least 10 points, to be honest with you. You need quite a few because these things curve a lot. Not all of them, but some of them. The last one was a line, but it took us some points to figure that out. So anyways, usually about 10 points are sufficient to understand the graph. Now you don't always have to pick the same values I pick, but you got to make sure you get enough to understand it. So I'm just going to put this table in here, and these are what we're going to start with. So I'm just going to do the same thing I did for the last one and pick every pi quarters. So that's 0, that's pi quarters or pi fourths, pi halves, 3 pi quarters, pi, 5 pi quarters, 3 pi halves, 7 pi quarters, and then 2 pi. So again, I'm going to just go through and find all of those values. So the first one, if I plug in 0 for theta, I know that the cosine of 0 is 1. So that's going to be 2 plus 2 times 1, so it's actually going to be 4. So there's my first one, so it's going to be 4. Now I'm just going to run through this, and I'm going to punch these in my calculator because, again, I want those decimal approximations because I have to graph these. So that's what I'm going to run through now and just do the table. So these are our values. So again, remember our first ordered pair is going to be 4, 0, and that comes from here. So that's what I'm going to graph first. So at the degree 0, which is straight across here, it's going to be 4. So 1, 2, 3, 4. So there's my first point. And then from there, I'm going to keep going. So then the next one at pi fourths, which is here, is going to be 3.41. So it's going to be a little less than half. Okay. Oops. And the next one at pi halves, it's going to be 2. So that'll be here. And then my next one at 3 pi fourths, and 3 pi fourths is here. That's going to be 0.59. So a little more than half. And then at pi, it's 0. So on this line right here, it's going to be at the origin. So then at 5 pi fourths, which is here, it's going to be that 0.5 again. Oops, that's too high. There, that's a little better. Okay, and then the next one then is going to be at 3 pi halves, which is here. And that's going to be 2. And then at 7 pi fourths, which is here, that's going to be 3.14. Oops. So then that'll be there on this line here. And then it'll be at 3.41, so a little less than a half. And then I go back to 2 pi, and it's 4. So there it is. So that's my picture. So now I'm just going to fill it all in. So remember, I have to follow it just the way it was pictured there. So there's the picture. And that's what you'd have to do for a test. You'd have to show all those values, show those points, and that would be your complete graph. There's no x-intercepts, y-intercepts I got to worry about these graphs. Just simply going through those values and plugging them in. And again, that's important that you put all the values down or you will lose points. Oh, there it is. In the original directions, they said also to give its name of what kind of graph it is. And this is called a limacon. And that would be, just so you know. So there's quite a few of them. Actually, really just about 4 different ones that we have. We have Limacon, we have circles. You guys already know circles. And they have these ones called lemniscates. And I'll talk about those as they come up. Actually, I'll give them to you now. So here are some other types. So for this first one, this is what we just graphed here. This one here. So that's one we graphed. That was the Limacon. This one in the middle here is a lemniscate right here. Lemniscate. And this one on the right here is a rose. So now keep in mind here that they don't always look like these particular pictures. Like this Limacon could have a little loop on it. You'll see those sometimes. That's still a Limacon. This one could have more petals on it. I could have 6 petals, or I could have 4 petals. I could have all different numbers of petals there. And even though this looks like it would be petals, they're not. That's a lemniscate. And those are only 2 petals always. And sometimes you'll see these where they're twisted this way. It's usually just a rotation of it. So that's about the gist of all the different sorts of graphs that we have in polar graphing.